Hi everyone. So in this video, what we're going to be doing is we're going to be analyzing the links in some technical objects. I highly suggest that before you watch this video, you watch the previous video going over the characteristics of links. So what we're really going to be focusing on is we're going to be focusing on looking at some technical objects. So in this series of videos, we're going to be looking at the link between a handle and a cup in a mug. We're also going to be looking at the links between a door and a wall. And then we're also going to be analyzing the link between a pen and a pen cap. Now, when we're analyzing a link, the key thing is we need to look at the four criteria. So our first criteria, whether the link is direct or indirect. So again, if there's a linking component putting those two items together or not. The second characteristic is if it is rigid or flexible. So again, if it's rigid or flexible, are the materials in place rigid? So do they keep their shape and not deform? Or are they flexible? And in this case, only one material out of the two needs to be flexible to be able to deform and go back to its normal shape. Our third characteristic is probably one of the easiest ones to visualize if it's removable. So can the two components come apart, or if it is non-removable? So are the parts permanently connected in the sense that if you try to take them apart, they incur damage? And then we're going to be looking at whether we have complete. So are the two components stuck together? Is there no independent motion between the two? Or if it is partial, meaning one component can move independent of the other component. So this is what we're going to be focusing on while we look at our different objects. So our first is what I said, between the handle and the cup. So our handle is this component right here. So that's the handle. And our cup is this right here. Well, first and foremost, our link is direct, for the sole fact that the cup and the handle, they're both made out of clay. Right? It's a porcelain, it's a clay cup. So you have clay, they're molded together and they're basically set into spot. The second thing is that it is rigid. Again, because it is made out of clay. Clay is a very rigid material. It's a material that can withstand a lot of force, but, and you probably know this, if you've ever dropped a mug on the floor, can potentially shatter. It is, due to the form, how the handle and the cup was made, because they're molded into one another, it is non-removable. If you take the handle off the cup, you've broken those two materials. And because in this case, it is also complete. There is no independent movement between the handle and the cup. If there was, you would have broken the material. So we're going to actually look at now the link between the door and the adjacent wall. So we're going to have a video playing. So in this video, we see the movement of the door hinge. So we have the door and we have the wall. And then we actually have from the other angle of the door and the wall moving. Okay, so again, we have our hinge right in the middle. So I'm just going to circle our hinge in red. So this is our hinge. Oh. We have, let's just erase this part. Hinge H-I-N-G-E. We have our door here. We have our wall here. Now the first thing that I can notice in my how my door and my wall are connected to each other is I have that hinge, and the hinge itself is connected into the wood by screws. And this is actually extremely important because screws are one of those linking components that can be removable. So first and foremost, if I'm looking at the link between the door and the wall, it is indirect. And it's primarily indirect because I have my hinge that bridges the two together. It is also rigid because my door is made out of wood, rigid material, wall, fiberboard, rigid material, and then the hinge itself is made out of metal, rigid material. It is, in this case, removable. And the key thing that I need to remember is that my hinge has screws. And screws makes the material removable. Let's say, for instance, the hinge was attached to the door with nails. Well, then that would be non-removable because nails are used for a permanent type link. And then my last characteristic is that it is partial due to, of course, the hinge. The hinge allows the door to move independent of the wall. Okay, so now what we're going to see is we're going to see the link between a pen and a pen cap. So we have our pen right here. And we have the pen cap. So if we're looking at our pen and our pen cap, the first thing that we can definitely say is that the link between the two is direct. The pen and the pen cap snap into place, and we don't actually need anything to hold the two together. The next thing that we can say is that our materials, just like before, are rigid. The pen is a particular rigid material and the pen cap as well. As we saw in the video, the two materials are removable, which makes sense because if you have a pen and you have a pen cap, you want the cap to come off the pen so you can use the pen component. Now, the last criteria is that it forms a complete link. Now, you're wondering, well, there's motion between the two parts. Yes, but we need to remember that complete has to talk about, is there independent motion between the two parts once they've been put together? And here's the other thing, that motion has to be part of the function. So yes, you can make an argument saying that the pen cap does rotate when it's on the pen, but the question is that rotation part of the pen cap's function? No, the function of the pen cap is to snap onto the pen. So I hope this helps, and have a great evening.